Hello everyone, welcome to Geeks for Geeks practice. So today we are going to see a question that was asked yesterday in problem of the day, and the question is word break try. So let's go and have a look at it. So in order to understand this question in more detail, let's go and have a look on the whiteboard. So the question says word break try. Let's try to understand this question in detail. So given a string A and a dictionary of n words with the name B, find out if A can be segmented into space-separated sequence of dictionary words. So this is my string A, I like. This is the dictionary B, which has basically n equals to 12, so 12 words. And we need to find out if A can be segmented into space-separated sequence of dictionary words. So if you observe, if I take I like, so can I segment this into space-separated sequence of dictionary words? I think yes. If I have segmented, okay, basically I am segmenting it into space-separated sequence. So I find that, okay, this like is also in my dictionary and I is also there in my dictionary, right? So I can say that I am able to segment A into space-separated sequence of dictionary words, right? Hence, the output is 1. So, as the word break function says, it takes a string, which is nothing but your A, and a list of strings, which is nothing but your B, as a parameter and returns 1 if it is possible to break the words. Alright, so over here it was possible to break, right? Break this I like. Basically, we were able to segment A, which is I like, into space separated sequence of dictionary words, right? And we find out that this is a possible or valid word in dictionary as well as this is also a valid word in dictionary, right? Hence the output was 1. Otherwise, if it is not possible to break the words, you need to return 0. You don't need to read any input or print any output. It is done by driver code. So we will see all these things if required on the Geeks for Geeks practice portal. Okay. I hope the question is clear to you guys. Now let's try to understand the logic to solve this question. So let's say I have the given dictionary as A, AB, ABC, DE, CDE. And let's say I am asked to find out, can I segment ABCDE into space separated sequence of the words present in this dictionary, right? So what I see from here is I have more than one solution. Like I can segment it like this, ABCDE. I can again have ABC together and DE separate, right? Great. So there is a very important visualization over here. Please have a look at the initial characters. So this AB, this ABC. Can I say these are prefixes of the string ABCDE? Like what prefixes can I have? I have A, I have AB, I have ABC, I have ABCD. These are all my prefixes, right? After this, obviously there are letters. Like I have BCD, I have CD. But if I talk about prefixes, these are my prefixes, right? All right. So if you carefully observe, I am going to basically search for my prefixes. So what we are actually doing, we are saying that fine, if prefix is there, let's say AB is there, so then I am going to search for CD. What if AB is not there? If it is not there, then you are going to your next prefix, that is ABC, and searching, is ABC present? Let's assume it is present. If it is there, you're going to search for rest of the letters in your given string, right? If ABC is also not there, you're going to check whether ABCD as the prefix is there in my dictionary or not, right? And if it is there, you are again going to check for the rest of the letters, that is E after that, right? So we are going to somewhere utilize this knowledge, okay, in order to frame our entire logic. So let's have a look at it. Let me give you a visualization how we are trying to do. So let's say the given word is A, B, C, D, E. Now, see, this is not my exact solution to be honest, okay? But right now I am trying to frame the logic. So what I am saying is, over here I have this as my string, right? As my word. So what I'll be doing is I'll be searching all the prefixes, okay? So initially I search for A. So A is found, then only I am going to go for B, C, D, right? And if I go further, then again I check for this B, like this becomes my next string. I check for this B. If this B is present, then fine, go for CD, else go for the next prefix of this. Check for BC. Okay. So BC is also not there. If you observe in the dictionary, BC is not there. So you're not going to make any calls. You're going to check for BCD. So BCD is also not there, right? Then BCDE you are going to check. So BCDE is also not there. So there will be no calls from here. Okay. And after that, what you do, you see that, all right, fine, you're not able to do any, you're not able to get any solution from here. You go to the next prefix. So you go to AB, right? And after, if you have seen that your AB is present, which we see over here, right? So you're making a call on CDE. Now again, the same thing happens for here. You have C over here. Let's say you're going to check whether C has a prefix present in the dictionary or not. So it's not there. So no calls. After that, you check whether CD is there in the dictionary. CD is also not there. Then you check for CDE. Yes, CDE is there. Then you're going to call on empty string, right? There is nothing left after that. So this will be somewhere a recursive solution. And when we find an empty string, we are going to return true. Obviously, because you have found your rest of the letters, right? So you're going to return true from here, and this gives you one solution, right? A, B, C, D, E. A, B, and C, D. E. Like A, B separate one word, C, D separate another word, right? And once you have found that, that's enough. You can straight away output one, right? So we'll see how we are going to output one from here. But I hope the logic is clear to you, right? If it's not, don't worry. Things will become clear when we go through the code, okay? So guys, over here we have talked about prefixes, right? So if you read the question has a word called try. So we are going to use try to search our prefixes. Now before going into exact searching in try, let's try to understand what is a try. So try is a very special data structure which has nodes and edges. Now let's try to have a look at how a try node looks. So this is in brief how a try node looks. Don't worry, we will go into the exact details when we see the code. So basically it has a try node array of length 26 and a boolean variable. Now see, so basically why we need a try node array of length 26, why we need a boolean variable, all these things will become clear as I proceed further. Okay. Guys, let me tell you that tries are basically used for dictionary like implementation, for implementation of searching prefixes. So in order to find out prefixes in try, first of all, we need to have that particular word in the try, right? So let's try to understand how we can insert strings or words in try. Let's say the words are AB, ABC, BC, and BCA. We want to insert these four words in the try. Please note that we are nowhere storing character in the try shown in this video, because if you observe, the try shown in this video has the try node, which contains a try node array of length 26 and a boolean variable. So apart from boolean variable, if you observe the try node array, each of its element can either be itself a try node, which will again follow this structure, or it could be null. So characters are nowhere stored. I hope you understand this. So now let's have a look at it. So initially we have a root node which has a boolean variable. Let's say we name it as end. There is a reason we have named it as end. We will eventually realize, okay, as we proceed. And we have a trinode array of length 26, where the indexing is from 0, 1, 2 till 25. Alright, so initially we start from the very first word. We are at the character A. We go over here. Our pointer is pointing to this root node, and we check whether the index 0, which points to basically what we do to find the index. We subtract. Basically, we do a minus a, then the ASCII value subtraction gives me 0. So I go to this index, it is null, which means I don't have any reference of any other trinode stored over here. So I create a node for A. Basically, this is how it will point to another node. So don't worry, guys, things will become clear when we see the code. So after that, my pointer moves over here. Okay, and we again have an end variable that is a Boolean data type, and I have a trinode array of length 26, right? Great. So now we come to this character B, and we do B minus A to find out the index, which gives me 1, right? Now we check whether the index 1 is null or not null. So it is again null. So we create one more try node. We have end variable of Boolean data type and our try node array of length 26. Our pointer comes over here. This time our word is finished, right? So we'll make our end to true. Now, first word is finished. Let's go and have a look at the word ABC. So again, we start from the root node and we look at the 0th index for the character A. It is not null, which means there is a node for A which is present. So we come over here and we check whether there's a node for B present. Yes, because the first index is not null. So we come over here and we check whether if we do C minus A and we get second index, so does the second index is null or not null? So it's null, right? So we create a node, right? There is a Boolean variable end, and there is a trinode array of length 26. The pointer moves from here to here now, and this is the last character, so we make end equals to true. So ABC is also done. Let's go for BC. We again start from our root node. We find that for B the index is 1, which is null right now. So we create a node. Let me create some space, which has a end Boolean variable and a trinode array. After that, my pointer moves to here, and I look for this character C, which is C minus A equals to index 2. Basically, it takes ASCII values and do the subtraction. Okay. So at index 2, what I found that it is null. So I create a node. Again, it has a end Boolean variable and a trinode array, and my pointer moves to here. So I see that this is my last character, so I make end equals to true. After that, I have BCA. So I start from the root node. I see that this position is not null, so I have a node for B. I come over here, I see that this position is also not null, so I have a node for C. I come over here and find that this position is null, right? If we do A minus A, we get 0. So this is null. That means we will create a node and our pointer moves to here. We have a end variable and we have a trinode array of length 26. As there is a last character, so we make our end to true. So I hope the insertion in tries is somewhat clear. Don't worry, we will go to the code and we will have a look at it in detail. Now let's go to our Geeks for Geeks practice portal and let's have a look at the code for insertion and searching in tries. Along with that, the recursive function that will help us to find out our final solution for this question. Now let's have a look at the code. So we have a class try node inside which we have a try node array with the name children and a boolean variable with the name end of word. This class has a constructor in which we are initializing our try node array with the name children with the length 26 and running a for loop and initializing all the try node. Basically, if you see, this is your try node array. So initializing all of them with null and end word with false. So this particular class has the constructor and two functions, insert, search. And obviously we have a trinode array and a boolean variable. Great. So before going into the implementation of this particular solution, let's first try to understand the insert and search functions of the try, okay, of the class try node. Okay. So let's have a look at the insert function. All right. So let's say if you want to insert a string somewhat like A, B, C, D, E. Okay. So what you need to do? Initially, a root is passed. Okay, let's go and have a look at it, how this root is passed. So if you observe over here, we have created an object of try node class that is named as root. And the constructor is called, right? So basically we will be having these initializations in the try node, right? Which is created with the help of this line number 117, right? After that, we are running a for loop and inserting all the words present in the dictionary, that is capital B, into my try. So let's go and have a look at the insertions in the try. So we have the root over here, and let's say the string which we are inserting from the dictionary is A, B, C, D, E. Okay. So initially, this root node will have an end of word, right? Variable, Boolean variable, which will be initialized with false, and a try node array where all the values will be initially null, right? So we come into this and there is a variable cur of reference try node which will also be point to the root, right? Now as you proceed forward, what you see that you are running a for loop on your str.length, so basically over this entire length, and every time you pick a character, let's say you first picked a character A, you checked its index, right? So it index comes out to be 0 right now, right? As we discussed in the logic, or while I was going through the brief explanation how we do insertion in tries. So we are doing A minus A, which comes out eventually to be 0, the subtraction in terms of ASCII values. And you check whether your cur dot children index. So basically cur is pointing to this. This is your children array, right? So index, basically this index you are checking. If it is null, then what you need to do? You need to create a new try node and reference will be stored at that particular index. So basically from here you will be having a new try node and reference is stored over here, right? Great. So after doing that, what you have done, you are moving your curve from here to here. Right. So if you remember, this is what I showed somewhere in the explanation. We'll have end of word also now, right? Which will be false. Why? Because of the constructor, and we have seen, right, in the constructor things are becoming like end of word is going to be false, and here let me just go a bit up. Yeah, so end of word is becoming false and all of them is initialized with null, and so on it will go for the rest. See, for the next time I will get incremented, so it will go to this character B, right? Your your cur is over here. So in this, whether b minus a or the first index, that is the first index, is it null or not null? So it's null. Okay, so we do the insertion. Okay, similarly, see, I am not writing every time end a word and all those things. I hope you understand. So over here again, we have a trinode array, and this time your I moves and your cur also come over here. I becomes 2, right? So yeah, just a second. Yeah, I gets incremented, it becomes 2 and it comes over here, right? So your cur is over here. Now over here you check, do you have the second index? Basically c minus a gives you 2, right? So second index is this one. If this is null or not null, so this is null. So again you create a node, right? And after that again similar checks. Okay, after that you again your cur pointer moves over here. You check whether your third index, right, for d, basically d minus a, if you do, it will gives you it will give you 3, right, in terms of ASCII values. So this is again null, right? So you will create one more node and so on. Like if you go with the e, okay, the value comes out to be 4. So 0, 1, 2, 3, 4. You again create one more node, right? And finally over here, after you have created that, you will exit out of this for loop because your string length has ended, and your cur right now points to this node, right? Great. So if it is pointing to this node, you will mark your end of word to be true. So over here for the node e, or see, this is intuition. Intuition in the sense, I'm not saying that I am somewhere storing character e. A character, see, because your trie node only has a trinode array of length 26, right? And a boolean variable end of word. So over here we make this to true, which means the end of the word. So first word ABCD has got ended. Now let's say next time you have come up with some other word. Okay, I will keep it quick now because I need to go into other functions also. So let's say next time you come up with AB, suppose. So you start again from here, right? You have your A as not null. Great. So you go forward. Over there you check for B. So your B is again is not null. So what will happen after your for loop ends? You are making over here your end of word will become true, right? Because you have a one valid word AB also. So I hope this is clear. Now let's go to the search function. Okay. So let me just erase some part. Yeah, search function is also very similar. Let's say you want to search for AB. Okay. So initially you have your cur pointing to root. You traverse through your entire string. You take the first character. So let's say you took A. You see the index. If it is null, you straight away return false, right? So initially, if you're over here, this will obviously not be null because it is pointing to a node, right? Basically, you will not be returning false. So what you do cur equals to cur dot children index. So your cur now starts pointing to this. Now next time you will be pointing to B. It again checks for the first index over here, right? So first index is also not null. Hence, you don't go inside this if block. You do cur equals to cur dot children index. So as soon as you go over here, now your cur starts pointing to this, right? Now your for loop gets finished. For loop gets finished and you check if cur is not equals to null, that is obviously not equals to null. It is pointing to a node. And cur dot end of word equals to true. Obviously, see, cur dot end of word is equals to true. That means you have found AB, right? That means AB is found. So that means you are able to successfully search. Now let's say instead of AB, let's say you suppose you were searching for AE. Then what could have happened? Then obviously this would have given false. How? For the very first time, when you see, okay, this is not null, right? So you come over here, your curve pointer is pointing to this, right? Curve pointer is pointing to this, and you check whether you for E, right? For the corresponding index of E, do you have null or not null? So over there, obviously, you will get a null, right? Because you don't have reference of that node. So it will become null and it will return false, right? So I hope this is making sense. Okay, the search function and like the insert function. Okay, so that's great, guys. Now let's come to the main function word break. Okay, where we were supposed to write the code. So initially we have created a root node. Okay, in the try node. Okay, in the try basically. So we have a root and we are inserting all the words of array list B, basically whatever words we had into our try, right? So we are calling root dot insert into this root dot insert, and we are passing first root and second b dot get I, basically the string. So if you observe over here, this is the code in Java. Let me go up. Okay, I have created a separate class for try node. See, it starts at line 33 and finishes at line 92. So in this class, I have a try node array named children and a boolean variable name named end of word and the try node constructor. Apart from that, insert function and search function, right? So over here, with the help of the object, basically root, we are calling root dot insert of that class, right? And what we have passed the root. Along with that, we are passing the words or strings which we need to insert, right? So we have already seen that insert function. So we know that after line 119 gets executed, basically after this line, my try will be filled with all the words present in the dictionary, right? Okay, after that we are calling word break util a function which is this, in which we are passing the string and the root node, okay, of the try. So this is a string and the root node. Now let's come over here. We'll see this code later. So this is a return type of boolean. So just to give you an overview, it could return true or false. So if it returns true, that means I need to return 1. If it returns false, I need to return 0. As simple as that, right? Now let's come to word break util. Let's try to understand this word break util with a very simple example. Okay, let's say I have a string called I like Samsung. Okay, and or just a second, let me do one thing. Let's try to take a test case, okay, from the Geeks for Geeks practice portal. Let's take this test case. Just a second. Yeah. Yeah. So if you have a look at this test case, now if you take a look at this, I have already inserted all the strings in my B into my try, and I have called word break util with the string A, that is I like, and the try node root, right? So I know that this is present. How? See, because I see I and like over here. But let's try to go with the algorithm. Okay, let's see how it goes. So initially a dot length is not equals to 0, right? So we come over here and we start checking for all the prefixes. See, prefixes, how we are checking, I'll just show it to you. So initially in the root dot search, we are passing root comma a dot substring 0 comma I. So this I is not included. Okay, so basically we are just passing the 0th index, not 1, because the value of I is 1. So this is how substring operation works in Java. This end index, basically 1 less than the end index is taken. Okay, so this will only pass I. So the very first prefix you are passing, you are searching it. Okay, if this comes out to be true, okay, which will obviously comes out to be true because this is there, right? This is there in the dictionary. Then only you are going to call word break util again. This is what I wanted to explain, because if you remember the concept of short circuiting in Java, there is ampersand check over here, right? Basically there is and check. So if I find first false over here in the first condition, there is no point checking word break util because eventually it has already become false, right? So if this is true, if the first part search is true, then only we are going over here. So what we do, we again call recursively word break util on full I comma a dot length. So what it will do now, it will call on like, right? Great. This again goes to word break util. This length is again non-zero. Again for this it is going to do all the checks. Now it searches for a dot substring 0 comma I where my a has become this, right? So basically I is again become 1, okay? So I am searching for L, right? It is not found. It is not found over here. So I'm not going to call word break util. This is what you need to understand, right? Then what I do, let me just clear some space over here, okay? After this, what I do, I go to the next iteration of my for loop and the value of I increases. So I am searching for Li. Okay, that is also not there in the dictionary. So again, what I have, again the value of I increases and I search for Lik. This is also not there. Then I search for Like. Okay, so this time I found and I'll be calling this part on a dot substring I. What is I right now? So I has eventually reached to the last in the sense, see when you called 0 comma I, what you did, you basically called 0 comma 4, okay? So I has become 4, okay? So this will eventually give you an empty string. So you go for a call and you see that, okay, if this length is 0, so what you are doing, you are returning true. So this returns to true from here. Okay, so where will this return? This will return to the call of I, right? So if you remember, the call of I was true itself over here because I was found, and eventually you get a call true from the like. So this will again return the true, and you will finally go to your bottom from where this word break util was called. So this res is true, right? Hence you are returning 1. So I hope the code is clear to you guys. You can do a dry run on more complex inputs for the code. Okay. And if you have any doubts regarding the explanation of today's video or today's question, do let me know in the comment section. Okay. Now let's try to compile this piece of code. Okay, so it gets compiled. Let's try to submit it. Okay, guys, so we are getting the correct answer. That's great. So that's it, guys, from my side for today. Thank you. Thank you for joining Geeks for Geeks practice.